Okay, with that said, I'll turn it over to Justin McBride to teach us a little bit about building assemblies.
Okay, thanks, Justin. Well, welcome everyone to another Justin on Friday morning. As he said, this is going to be our third webinar on grass waterway design in Civil 3D. Keep muting me. You must not like what I said. But anyhow, what I was saying was this is our third one for waterway design, and the first one was how to develop a surface. The second one was how to do an alignment and a profile as well. So this is the third step, creating assemblies. We use assemblies for many things, mostly linear projects in Civil 3D. Basically, it allows us to cut or put a groove into the existing surface and then create a finished design surface, which is what the project will end up looking like. If you can think of an assembly once it's completed, think of it kind of like a grouting tool. If you ever laid any kind of block or put any grout in, you have to have that special spoon shape, and that puts that groove right into the grout. Well, that's almost like the assembly. We're going to cut right into the ground what the shape of the waterway is going to be. Okay, so it's not a cross section, but it's what the cross section will be built from. So again, we've already completed the alignment and profile from the last webinar, and we're going to start right from there, and we're going to move right into creating an assembly. I will say that we didn't send out any emails yesterday, but the instructions for this, just like all the other ones, they are on the presentation little menu there on the right. You should be able to see an assembly Word document there. If you do, go ahead and open that up, and you can either watch it while I'm talking or you can print it off and make notes, whatever you want, but it is there, so make sure you go ahead and download that and open it. Okay, let's go ahead and get started. You can see my screen here, I hope. So over here on the left, I have my surface that I've created, as well as the alignment on it, and on the right I have my profile that I've also created. And I'm just going to go ahead and jump right into it. The first thing I want to do is go up to the Home tab in the ribbon. And down here next to Tool Space, there is a button. If I hover over here, you see it says Tool Palettes. Okay, it's there. We're going to be using that. But first, the first thing I want to do is go over to the Create Design tab and click the Assembly and hit Create Assembly. And you could have also typed in the command Create Assembly in the command line. Okay, so what I want to do is I want to name my assembly, and this assembly is going to be for a grass waterway that is 40 foot wide and 1.2 foot deep. Now these are calculations that I've done through EFT, that I've already done the preliminary calculation. I know that's what I need. Okay, so I just want to make sure that I do label it something like 40W for 40 foot wide and 1.2D for 1.2 foot deep. And I can even put a P if I wanted to be sure that it's parabolic, but I'll be able to see that on the screen anyhow. Okay. So I want to make sure that the assembly type is other, and the style is the basic, and the code set is to all codes, and just click OK. And now I have to pick some spot here in the white space. Now I just want to be sure that I'm outside of any viewports or any type of aerial image that's going to have a background, because this isn't something that isn't that is going to be shown in the plan. So this won't be shown on the plans, but it's going to be needed to be stored in the model space to where you can find it and manipulate it in the future if you have to. So just pick a spot that's going to be out of view, somewhere over here, and click, and then it pops up with this red line with a circle in the middle. That is your assembly. That's going to be the center of your grass waterway, right where the gray line is. Okay, so if your grass waterway is 1.2 foot deep, that is right there at the bottom of the waterway, 1.2 foot deep from the edges. Okay. Now, if you're following along, this is step 2, where we're going to start creating the sub-assemblies. Okay, so right now on the screen is the assembly, and to that I'm going to attach all the sub-assembly pieces that's going to develop the cross-section of the grass waterway. Okay, So again, up here on the top left in the Home tab, right next to the tool space, there's this button that we call the tool palettes. I'm going to click that, and on the right on my screen, you should see this tool palette menu that just popped up. Okay, these are all the commands we're going to be using for these sub-assemblies. Okay, they have different purposes. Most tool palettes command up here in the top left. Okay, that'll open up this menu on the right. This menu on the right's got all of our sub-assemblies we can use, but the ones we're going to start with is here on the generic tab, so make sure you go to the generic tab, and I'm going to be using length, width, and slope. Okay, so I'm going to click length, width, and slope, and right here in the middle of the screen you can see my cursor's a square selection box, and I just want to select the red circle that's on the assembly right there. And I get this purple subassembly line that's not at the right width and slope right now, but that's something we can change once everything's done. So this is the first one I want to do, but for a parabolic waterway I need two more, and I'll explain that once it's done. But for parabolic, you always want to have three on the right for these first ones, and then one on the very end. So I'll explain it once it's all done, but basically I want to do this two more times. So I come to the far right of this subassembly that I just created and select the circle. Okay, so if I zoom out, now you can see I have two of these lines, and I want to select the far end of the second one. Okay, so now I have three of these subassembly lines. Okay, again, none of them are at the right width and slope that I want, but I'll change that here in a second. So I'm going to go ahead and hit enter, and I'm not quite done yet on this side. There is one more step that I have to do. I have to add what the program calls a daylight subassembly. And the purpose of the daylight subassembly is when this cuts through the ground, if this far end ends up being above the ground or below the ground, it'll tell it how far out to cut at a certain slope before it finds the existing ground line. So to do that, I go over on the tool palettes menu and I select the daylight tab, and under the daylight tab I want to click daylight max width, which is this one right here. So I'll select it, and so again in the model space my cursor is now a selection tool. I'll click the far end of the last subassembly we just created, and I'll have something weird. It's got these dotted lines on the screen with these slopes going on everywhere. Okay, so I can hit enter again, and I have half of the subassemblies that I need. And the process is, once I get everything done on the right side at the right length and slope, I'm just going to use a special mirror command that's going to copy it and put it on the other side. So it's fairly easy. But right now, let's go ahead and adjust all these slopes. If you're following down the notes, this is, I believe, step 2L. Okay. The first thing I want to do is select the first subassembly closest to the assembly line, which is this one here. And up in the ribbon tab, you can see that it changed to the subassembly ribbon. And I want to go to the SubAssembly Properties. So I'm just going to select that. And then it'll pop up this the SubAssembly Properties dialog box. And I want to go to the Parameters tab. This is where I'm going to set all the types of parameters that's going to dictate how long this subassembly is, what's the slope, and so forth. If you're following in the notes, this would be step 2M. I'm about to start setting parameters. So if you go down there to where it says the first subassembly parameters, the width is always, if you're doing parabolic, again, this is for a parabolic waterway. I'll talk about a trapezoidal one once I'm done. But for parabolic, this first line width is always a quarter of the waterway width. So since I'm doing a 40-foot waterway, I want to take a quarter of that. That's 10 feet. Okay, and that this subassembly is already defaulted to 10 foot, so that's okay. The second thing I want to change is the slope of the subassembly. Okay, right now it says 2%. Well, if you go down there to part 2, it says my slope should be 100 times the depth and then divided by the waterway width. Okay, so that's 100 times 1.2 divided by 40, which is 3%. So I'm just going to click this, double click it anyhow, and I'm going to change that to 3 and just hit enter. And that just changed to 3%. So I'll hit OK. And I don't know if you can see or not, but it just barely pushed this first subassembly up a little bit because it increased the slope, and that's okay. So I'm going to do the same thing for the next 2 subassemblies. So I'll select this one, go to SubAssembly Properties, Parameters, and this should be on the back side of your step-by-step guides. The second subassembly should be the width is 1/8 of the waterway width. So if it's 40 foot, 1/8 is 5 foot. So I'm going to change 10 foot to 5, hit enter. And my slope is 2 times that of what the first one was, which was 3%. So 2 times 3 is 6%. Hit enter and just hit OK. Okay, so you can see that one changed that one a lot because we changed the length of it. It's shorter, it's half the length of the first one, and it's a little bit steeper than the first one as well. Okay, so I'll hit escape. I'll select the third one. I'll go to the Subassembly Properties box, go to the Parameters tab, and in this one, if you're following in the notes, again, this is the same as the last one, 1/8 of the waterway width, which was 5 foot. Hit enter. And then the slope this time is 4 times the first one. So if the first one was 3%, then this one is 12%. Hit enter. And hit OK. Okay. That looks right. Okay, now the last part here is this this daylight tab. So again, what this is going to do is this is going to cut through the ground at this shape, and as it goes through there, this end has got to be able to find existing ground somewhere. If it's below existing ground or above it, it's still got to be able to find it. So what this fourth part is, this daylight, it'll say, okay, from this point I'm going to find existing ground. If it's below me, I'm going to go down to it at a certain grade. If it's above the end, I'm going to go up to it at a certain grade. Okay, so what I'll do is I'll select this daylight. I'll go to the subassembly properties like the other ones, go to the parameters, and you can see that it's got different types of values here you can change. And there's a bunch of them here in the daylights, okay? But the important ones are the first couple. Okay, so my cut slope is basically saying if the end of my waterway is below the existing ground, at what slope am I going to cut to get to the existing ground? And in the case of a waterway, you don't want that to be too steep, right? So if 6:1 is usually our minimum, then that's what we'll put in there. So in this case, I'll put 6:1. Now you can do 8:1, you can do 10:1. Whatever you use in the past is still okay, and you can change this if it doesn't fit later on too. And I'll show that here in a second. Okay, but right now I want to change my cut slope to 6:1, and my fill slope I want to change it to 200:1. And that's quite a bit bigger than 6:1, and I'll explain that coming up as well, but for now that's what I'm going to change, and I'm going to click OK. Okay, and it just changed those slopes of that the fourth daylight line there. Okay, so that takes care of the 4 subassemblies on the right of the assembly, but I still have to do the left side. And this is fairly easy, and this is something I just found out the other day. If you make a box to where you can select all 4 of the subassemblies, except do not select the center assembly line, just do all 4 subassemblies, okay? And then you right-click, and you go down to this command that says mirror, and just select it. And then I have to select this red assembly line because that's what's the center that it's going to mirror to. And after I selected it, you can see it just did the same exact thing on the left that's on the right. So all these parameters were copied over, they're just now on the left side. So now I have a completed subassembly inside my model space. The one thing I will suggest that I didn't put down on the notes is to put some sort of text up here that will say which subassembly this is. Because on many of the grass waterways we do, there's often times where we have different different widths, or not width, different depths, different widths of waterways, just because the slopes change or for different reasons. And so you might have several of these assemblies in there, each one's different. So you want to put some text here that basically says this is waterway 40 foot wide and 1.4 deep. So oftentimes I'll just do this, and I'll just type the same thing that I named the assembly, so 40W and 1.2D, and you can scale that up so you can see it and everything. But it just makes it a little bit quicker to be able to find it if you're trying to change something further down the process. So that's it. This assembly is created. Now I haven't shown you how to use it yet, but what I'm going to do is go ahead and change over to this other project I have open.
Hey Justin, before you do that, I'm sorry to interrupt. I've got a couple of questions or comments I'll throw in here now. Could you just use the link slope to surface in the generic tab instead, or what is there? Is there a different benefit to using the daylight command?
Well, let's find out here. So they said they use the length slope.
You got to go to the
surface. Which one? I'm not seeing link.
It's in the no, it's in the generic
right there.
tab, and there's right. Yeah, there you go.
Yep, right there it is. Okay, let's try it. I'm always open to new things. I've not used it before. This is just the one I usually use. But let's try it. Okay. I think
the answer to that is you can change your cuts and fill slopes and reaches if you want them to be different. You don't want to. You want to cut 4 to 1, but you want to fill at 10 to 1.
Oh, yeah, that would make sense. See here in the parameters tab, there's only one slope, so it will seek the existing ground one way or the other, but it will only do it at one slope, so 6 to 1, whatever it is. But from what I did, you saw that I did two different ones. I did a 6 to 1 and I did a 200 to 1, and I'll show you why I did that here in a second. But yeah, certainly you could use this. There's nothing wrong with this. Like I said, there's several ones here you can use. So if this one works in your case, sure, go ahead and use it. Just change the parameters to what you want to use. It looks like the important thing here is to change the slope, and you're pretty much good. But I don't have much experience with it. I don't know, Justin, do you have anything else?
There are a couple other tools there that you can, sub-assemblies you can add that probably get you to the same place too. And we thought about going through some of those, but then we thought we might just confuse people. So we'll just kind of go through the one. This is another alternative you could use. If you have a different way of doing it, that's good. I would encourage you to explore someday. It's snowing outside and see what some of those other ones do. If I stray too far from what I know, I end up getting into problems and things don't work for me. So I tend to stick with just that one. The other question came up, you could just check properties to find out which assembly it is.
Yeah, certainly you can do that. If I select this assembly here, I shouldn't even have to go to properties. If I select this red line assembly, it'll tell me up here in the top right in the ribbon. It says 40 foot wide, 1.2. So yeah, you could do that. You can go to properties and figure out what it is. All I'm saying is that if this text is here and if you scale it up to where you can see it, you don't have to do it. You just know that's which one it is. So yeah, you don't have to do it, but it's something I've always done and something I would recommend if you have a lot of these together. So, but that's certainly your preference.
Okay, thanks for those questions.
Mm-hmm.
And you can continue.
Okay. So again, I've already. You keep muting me. Okay, I've already done one where I've created the assembly complete, and that is right here. You can see it's the same one we just created. But I've also went ahead and built a corridor. Now, we'll talk about how to build a corridor in the next webinar, but for now, I went ahead and built it. And you can see I have this weird split screen, okay? Something I'll talk about when we do the corridor webinar, but basically this screen allows me to see the cross-section at different stations throughout the alignment. So in this case, I'm at station 300 all the way on my alignment, and I can see the cross-section based on the assembly I just created. Okay, so let's take a look at this this bottom screen here. This purple line, if you can see that right here on the bottom that I'm following, that was created from the assembly that we just made. And this top line, this red line, is the existing ground. Okay, so what this is showing is how this assembly is going to fit into the existing ground condition. Okay, this red line right here is my center line. Okay, so from this point here over to the top of the assembly should be my 1.2 foot deep. And this is kind of a weird section editor to kind of look around. When you zoom in and out, it'll change the box settings, but if I can kind of play around with it, you should be able to sort of see. So this left side here, this end point right here is right where the assembly cut through and stopped. Okay, those was the first three sub-assemblies we did that were the length, width, slope. Okay, that's where they stopped. And from here, the daylight tab said, okay, I have to go find the existing ground, and it went out here and found it. And it did it a 6-to-1 slope, so that's 16.7% slope. And it went there and it found it pretty close, which is pretty good. That's kind of what we'd like to shoot for. Okay, so that was the cut slope. Now, the fill slope, you remember, was 200-to-1 is what I picked. And I'll show you when I go over here to the right. Okay, this right here, if I can make a box, I don't know if it's not letting me make a box, but this is the end of the right side of that third length width slope subassembly. From here, it's saying, okay, now I have to go out and find the existing ground. I know I'm above 6. Okay, so I'm trying to zoom in here. All right, so it's saying that I'm above the current ground, and so I have to fill to get back to ground. Now, in the case of a grass waterway, I could have done a 6-to-1 slope, which would have taken this point and come down to somewhere right around here, which is fine. But if your ground tends to go up the further out you go, you may not want to have that much of a slope. So this 200-to-1 just gives me a flat slope. It's virtually a flat slope. Okay, so you're going up and you're building a flat area of fill until you meet the existing ground. And this is good because if you're dealing with any kind of water that needs to get in from the right side, what you don't want to happen is have a 6-to-1 slope to where it can't cross over to get into the waterway. This flat section basically says, okay, it'll still get in the waterway, it's just going to be a little flatter slope to do so. Okay, so again, with the last one you guys were asking about, it would have just cut straight down here and no water could have got in from the right side. But as you can see, this ground line keeps going higher and higher and higher, and eventually, if I zoom out here, it does meet up with the existing ground, and so all the water is going to flow from the high ground down across the flatlands into the waterway. Okay, so that was the purpose of why I did the two slopes of 6-to-1 and 200-to-1. Now I could have changed this, and before I get into this, I want to say something here. At this point, pretty much anything I do to this subassembly setup, it's all dynamic. So anything I change is going to change something on the corridor and then something on the section editor. So if I go to this space and I zoom in, select the daylight tab, and I go to Subassembly Properties, Parameters tab, I'll say, okay, I don't want 200 to 1 slope. I want to make this, say, 10 to 1 slope. And hit OK. Okay, this dialog box will pop up. You can hit the green check mark. It just changed my whole assembly here, which also just changed, I know you couldn't see because I'm too close in here, it changed the way my corridor is laid out. But inside the section editor, look, it's doing the same thing, except instead of 200 to 1, it's going to 10 to 1, and that's what I'm talking about, where the water's not going to be able to cross over this hill to get into the waterway until it builds up so much that it can do so. So that was the difference. Okay. So again, it's up to you, whatever you want to do, 200 to 1, 500 to 1, 100 to 1, whatever you want to do. It's just I would recommend doing a much flatter slope and keep experimenting with it. But again, this is all dynamic. So if I go out here and change, say, the grade, say for some reason I want to make a very shallow cut, say right here in my profile, I'll just move it up. And again, you get this box, you can hit the green check mark. And it just changed everything. It changed the whole corridor, it changed everything. And inside the section editor, okay, now I have 2 fill slopes. So that was the whole point of some of the earlier webinars, is that you don't have to have everything set in stone at the very beginning. All this stuff you can edit further down the line, and it all changes dynamically with it. So this will let you help you sort of experiment with the design and try to fine-tune stuff as you get further along. Okay, so just don't have the mindset that things have to be set in stone as you do them. You can always change them later, and everything should flow the same. The one thing I'll say is that I'm doing this in AutoCAD 2017. It's the exact same in 2016 and pretty much the same in 2015. So whatever you have, it should be very similar for the last couple of years. The other thing I can do is I can change the actual subassemblies for the grass waterway part. If for some reason I wanted a deeper grass waterway, I could change this whole assembly to maybe get a 1.5 or 1.6, whatever it might need to be, and it'll change the whole corridor again. Okay? So that was my last kind of little point I wanted to say on the dynamic part of the Civil 3D. This was for a parabolic waterway. A lot of our counties are doing parabolics. Some of them are still doing trapezoidal. I'm not going to get into the whole debate of which one's better. I'll just tell you that this whole process can be used the exact same with the trapezoidal method. So when I started here in the beginning with this first subassembly, the only difference would have been is that I would have made this say a 0 elevation, or not elevation, 0 slope, so it would have been flat. And if I want a 10-foot bottom width, I would just make this one 5 foot wide and it would be flat. I'd do the same on the other side. And then once I get to my side slopes, if they were 8 to 1, whatever they are, I would just make that 8 to 1. And in that case, you would only need 2 per side. So it's fairly similar, and I can even do it here. I've got a little bit of time, but I'll just go ahead and create another assembly. And I'm just going to name this trap because it's just going to be a demonstration. Let me go up here a little bit so I'm not out of room. Okay. I'll just go to my tool palette and I'll hit length, width, and slope. Select the assembly. And I want a second one. And hit escape or enter. And I want a daylight tab. So I'll do daylight, what did I do, max width? I think that's what I did. Okay, hit escape or enter. I'm going to change this bottom subassembly. I'll just change it to, we'll do a 10-foot bottom, so I'll change this to 5 foot on the right side and a 0 slope for the bottom. Hit OK. And for the second one, I'll go to the SubAssembly Properties, and I'll change the Parameters tab to, I got to do a little bit of math. let's just say that it was a 35-foot or 36-foot total waterway. So 10 foot minus 36 foot is 16 left over, so that would be 8 foot on the top, and say I want 8 to 1 slope. 8 to 1 slope is 12.5% slope, and I'll hit OK. And I'm going to leave the daylight thing to 4 to 1. You can change that as needed, but again, I'm just going to select it, select both the subassemblies, I'm sorry, and right click, go down to mirror, and select the center assembly, and there I have it. Now I forgot to do the daylight one too, but you can see I have that nice trapezoidal shape, and you can do the same thing. You can use that to cut through your waterway, and you can design it from there on. So it's very similar. The reason I had to do a few more for the parabolic section was, if you're familiar with the standard, we have to do a 7-point check on parabolics. Okay, you have to check the center point, and you have to check the halfway widths, which would be about right here and right there. Then you have to check the 3/4 widths, which is right there and right there. Then you have to check the full widths. Okay, so if you're familiar with the standard cross section, if you look at the standard drawing on this, the 412 standard, it'll have all this in here. It'll say half width is 1/4 of the depth, and 3/4 width is 1/2 of the depth. Those are all the spots we're supposed to be checking in the field. That's why I put those points in there, so it gets a more accurate parabolic shape. So with that, I think I'm pretty much done. If there's any questions, or if any of you guys want to chime in here and just have me demonstrate some other things on some assemblies, just kind of type it in, or even raise your hand. I don't know, Justin, do we have any more questions?
Just one comment that it's a 9-point check with the dots outside of the waterway, but
yes.
Yeah, I think what you're trying to do is make sure you get the elevations within the waterway that we're going to survey close and not approximated by the line.
Right. Yep. Yeah, but that's a good point. Technically, it is 9-point check, 7-point in waterway, then 2 points further outside. That is a good point. We should be reminding people of that. So yes, it is a 9-point check.
We will go through the ins and outs of waterway design. Obviously, we do that in our TDP class. We'll have that coming up. I think most of you have been through that, but a couple of you are new or have not. We'll be doing that level 2 class sometime in this winter or spring. So we'll talk a little bit more about the hows and whys to designing a waterway. Another thing I'll add, so you saw Justin just put together an assembly for I don't remember what was it, a 40 to 1 foot waterway. Well, what do you do if you have multiple cross sections? We can create multiple assemblies for all the different possible dimensions: a 30 foot, 40 foot, 42 foot, 1, 1, 1, 2, etc., and the depth. And there are a couple of people who've developed libraries out there where they've already assembled some of these that you can do. You can start your own library as you go through designs, so you don't have to reinvent the wheel every drawing with creating more assemblies. I can see in some areas where you're doing 6, 7 different shapes on one set of plans, or that would get awfully tedious. So you can do that. The other thing I'll mention is, you see in the tool palettes the great 3-dimensional little diagrams that go with the various sub-assemblies. We did not get into the parameters and codes. I think in the very beginning Justin listed that as basic. It's a little bit more of an expert, I'll call it an expert level for skill, that can assign materials and calculate quantities on the fly. So you can see for roadway, highway design, where you've got very large projects with a lot of different layers of subgrades and pavement, that work gets much easier if all of that gets pre-coded during your design, and then when you finish your design, your quantities are complete, and then you can have your specifications all there listed to what gets seeded and whatnot. For us, it's usually a pretty quick calculation, so I don't know if it's worth trying to program all that in. Any other questions? Any other comments? Okay, another question. Is there a good way to design an assembly that goes from a road or fixed object and uses a different alignment for the waterway or ditch bottom? We have to use a dummy alignment.
Not sure I understand the question there.
Are you talking about putting like two alignments side by side or changing from one shape to another shape? Like a road ditch layover.
I don't know if the question is if you can connect two different type of assembly shapes or that, but when you do your corridor, you can add multiple assemblies to it and it'll automatically adjust to connect the two. I don't know if that was the question or not.
Or if you're, I assume you're doing somewhat of like an offset where maybe you want your alignment to be on the end, like a roadway edge. That can be done. It would get a little more complicated because you would have to draw your shape, your ditch shape, all to the left or to the right of that assembly. So you would have to come out maybe a flat distance of 5 feet, then do your down slope, your bottom, your up slope, and then daylight it. So yes, you could do something like that and have the whole thing offset. It doesn't necessarily need to be centered, but for most of our waterways and open ditch type projects, it's probably the easiest way to do it because we got both. We're designing to a low bank. In that case, you wouldn't be designing to a low bank. One bank would be fixed. So yes, you could do that. You can do this same process to do a small dike, levee, dam. If you, same thing, just flip it upside down. You're going to be, instead of drawing a ditch bottom, you'd be drawing a dike or dam crest with side slopes, daylighting to a bottom. You could do it for a core trench, a two-stage ditch, just drawing in the flat benches, three-stage ditch, or any type of shape like that could work real easily. You just have to pre-calculate your lengths and slopes. Okay, any other questions? Our next webinar will probably be in a month or so, and we'll put this whole thing together into a corridor. That'll be a little bit of a maybe more complicated discussion. And we'll assemble the whole project.
Yeah, that one might be more of an hour-long webinar. There's a lot of little steps and things that you have to get right to get your corridor to work just right.
Okay, with no other questions, everyone have an enjoyable Friday, a good weekend, and we'll see you back here in a couple of weeks in our next webinar.
See you later.
Thank you.